So, we were discussing about the bubble sort algorithm, and the approach as was discussed in the last class was that every element, every iteration pushes the heavier element at the bottom, and that is what we had, and the lighter elements therefore go up. So, we had shown an example, a couple of examples by which we can show that the heavier elements go down and the other lighter elements go up. We had given a number of examples to that effect. So, if there be 50 here, I do not know if it is visible, let me write it here, 50 here and 6 here, then and say 12 here and 7 here, then what will happen is 50 will be swapped with 6, because 50 is heavier than 6 or larger than 6. So, first it will be 6 and 50, and then 50 will be compared with 12, again there will be a swap. So, there will be 12, 50, 50 will be compared with 7. So, it will be 7, 50. In that way, ultimately the 50, if it is the heaviest, will come at the bottom. So, we swap only if the element at the top is heavier. Okay. Thereby, the heaviest element is coming to the top, and the others which are less than this, less than this heaviest element will be going at the top. The bottom moves upward. Now, we are going to write the algorithm for this, or the program for this. Now, before writing the program, we need to understand a very interesting and fundamental concept of C programming, that is pointers. We will not formally introduce pointers here, but we will be talking about pointers in a different way in the context of this bubble sort. Now, what is a pointer? Pointer is something that points, right. Now, suppose there is a variable here. Suppose the variable is named v, and till now we have seen that we can declare the variable as int v. Okay. Now, suppose I do not, so v has got a particular address, maybe that address is 1000. 1000 is the address of v. Okay. Yeah. Now, if instead, so if I say int v equals 50, that means in the address 1000, 50 is written. But now, suppose we have got this address v, and which is an integer, but I am not declaring v as such, but there is another variable p, which will always point to some integer. So, p will point to this v, right. P is pointing to this v. In that case, I can say p is a pointer to v. Now, so therefore, what did I say? I said that v is stored in the location 1000. Now, pointer p, this variable p, therefore, stores the value 1000. Okay. Now, this v is of type integer. So, v is of type integer. So, p is a pointer to an integer v. That we know, because v, I have earlier said that v is an integer. But say, so I can very well say int v. But what is the type of p? P is a pointer to v, which is an integer. So, we write that as int star p. What does it mean? It means that p is a pointer to an integer. If I write it, it is not concerned with v only, it says that p is a pointer to an integer. Okay. So, what is the value of p now? Value of p is 1000. We need to say, and what is the address of p? The address of p, now this, where is this p? This is in location 1000, and where is this? This might be in location 2000. Therefore, what is the address of p? End of p is 2000. We know that this AND operator gives us the address. We have encountered this during scanf when we are discussing about scanf, right. So, let us have these diagrams. To understand the concept of a pointer, suppose there are different things written in different pages of the book, all right. There is one page, this is another page, this is another page, and this is another page. Each of these pages have got a page number. Now, what I have got a table where suppose this has got some content A, this has got some other story B, this has got some other story C, this has got some other story D. Therefore, the content of each of these pages are the stories A, B, C or D. But which page I am looking at? Suppose here is a page number table. Table of page numbers. So, I have got there are 4 pages. So, the pages are 1, 2, 3, 4. Now, suppose I just want to come to this page number. So, this page number does not tell me what story is there, but this page number tells me that I have to go to this page. This entry is telling me, this particular page number is telling me that I have to go to this page. This is telling me that I have to go to this page, and this is telling me that I have to go to this page. So, what are these? What are these? What are these things? What are these? What are these? These are nothing but pointers to pages. And what is A? A is a content of the page. So, A or C or D say is content of page 4, okay. And these are pointers to the pages. That means, if I want to go to page 4, where should I go? Because this page may be located at some other table maybe. Suppose these pages of a book are torn out and have been kept on different tables. Okay. So, page number 1 is giving me the table address. So, that it is on this particular table. So, it can be on table T1. this can be on table T2. Maybe the third page is on table, the third page is on table T4 and this is on table T5. It is possible. So, the first table I have to, if I want to read the first page, I have to go, I will come here, okay, the first entry, this is the pointing to table T1. So, and I go to table T1 and find this particular page and read the content of that. All right. So, these are pointers to pages, but these pointers also have to be in some memory location. Let me draw the diagram in a different way now. Suppose this is my memory and I have got 4 variables. Suppose I have got 4 integer variables and each integer variable takes 2 bytes. I am showing 2 bytes here, one after another. All right. This is the variable V1. This is the variable V2. This is the variable V3 and this is the variable V4, right. And similarly, let me just change the color. So, these are suppose in locations, sorry, let this be in locations. V1 is in location 1000, assuming that an integer takes 2 bytes. This one is in location 1002, this one is in location 1004, 1002, 1000, 1004 and this is in location 1006. And let me extend my table a bit. Now, suppose I have got here again 4 integers. This is so this is sorry. Things are mixed up a little bit. I want to come to this. So, here I have got P1 is a pointer variable with, again since it is an integer, let me say P2, P3 and P4, if they are integer pointers. I am not bothering about that. I am not bothering about how many locations it is taking. Now, this P1 is actually, I am not bothering about this division here 2 bytes, I am just showing those 2 bytes together, that will be easier for me to write. All right. So, here the P1 is storing the value 1000. Why? P1 is a pointer to this variable. So, this P1 tells me not the value of V1, but it tells me where is V1 located. So, 1000 is the position where V1 is located. So, P1 is storing that pointer and P2 is say 1002, P3 is 1004 and P4 is 1006. Now, these locations also have got address. Suppose these addresses are 5000, 5002, 5004 and 5006. This is 5006. Okay. So, please try to understand, when I say P1, what is P1? P1 is a pointer to an integer. Okay. So, int star P1, that means that P1 is an integer, all right, and P1 is an integer, P1 is a pointer to an integer variable. Okay. It could be a floating point variable also. Had it been a floating point number, then suppose this V1, V2, V3, V4, I am just for the sake of clarity, I am just not bothered about how many locations variable is taking. I am just erasing this. Okay. Whatever it requires depending on the machine, that is taken. Now, suppose each of them is a float. So, float V1. So, V1 is a floating point number, right. V1 is a floating point number. So, then, and if P1 points to V1, then I should write float star P1. That means, P1 is pointing to a floating point number. Okay. So, since it is a floating point number, if I say now and P1, what will I get? What is the address of P1? If I try to get, this is not an assignment, what is and P1? What is the address of P1? Address of P1 is 5000, all right. And what is star P1? What is the meaning of this? Please do not be confused. This star and this star has got two different meanings. This star means it is just saying that P1 is a pointer to what type of variable? Pointer to a floating point type of variable. So, for V1 I am just writing float V1. So, that means that V1 is purely a floating point number, not a pointer. But when I say float star P1, then P1 is a pointer to some floating point number. Now, if I just, what is star P1 in this case? What is the content of P1? Content of P1 is 1000, all right. Content of P1 is 1000. So, let me just repeat it once again. So, we have seen in declaration something like int star P1 int V1, all right. Now, that means P1 is a pointer, P1 is a pointer, suppose located at location 5000, and P1 is a pointer to a variable V1, which is also an integer V1 located at location 1000, all right. These two lines are just meaning these two things, these two pictures. This 5000 or 1000, this part is not known to us, because that is known by the compiler, not by us, but logically to us this is the picture. Leave aside this 5000 and 1000. Only these two parts are declared by this. Now, if I say star P1, that means the content of P1. What is the content of content of P1, whatever is the content of P1. Now, if I make P1 to point to V1, in that case if I make P1 point to V1. So, what will that be? Content of P1 should be assigned to end of V1. End of V1 will give me the address of this, and the content of P1 will get that. So, therefore, this 1000 will be written over here. That means, this pointer is pointing to this V1. Okay. I will not go into further details of this right now. We will come to this as and when the context comes later. Right now, with this in mind, let us go back to the algorithm of bubble sort. What is being done in the algorithm of bubble sort? Let us try to understand each of the functions. First thing is, we have got the standard declaration, find no issue. Now, first let us start with this function, void bubble sort. Bubble sort is void because it is not returning any value, any value. It is just sorting some array. What array? X array, and the size of the array is n. Int ij, they are two local variables because they are used as indexes of these two loops. In this loop, what is happening? For I assigned n minus 1 to 0, I minus minus. That means what? That means, if I have an array here, this is my array, I have got I pointing here, because that is the size of the array minus 1. So, I is pointing here and it will go up to 0. So, gradually it will go in this direction up. That is what the first for loop is saying. Okay. First for loop is saying that I is starting from the bottom and going up to 0, as long as it is greater than 0. And then for j equal to 0, j equal to 0 to j less than I, j plus plus. If x j is greater than x j plus 1, that means what? If x j is greater than x j plus 1. So, let us again go back to this. J is starting from 0, and I am comparing this value 50 with the value 2 with j plus 1, this j plus 1. If x j is greater than x j plus 1, what would I do? I would swap. Let us go to here. If x j is greater than x j plus 1, I am swapping x j and x j plus 1. I will come to the swap function later. I am assuming that the swap is working correctly. That means, it is swapping them. So, what is happening? So, this loop will go on, j equal to 0, then j will be 1, in that way it will go on. And so, let us see again. So, next when I swap it, it becomes 2 and 50, right. Now, I have got other values. Now, j is being incremented. So, now this is becoming j and this is becoming j plus 1. In that way, this swapping will be done. Suppose this is 70. So, there will be no swap, no swap. So, let us see here. If this condition does not hold, swap is not taking place, I am going back to this loop, all right. So, sorry. So, now 70 remains here, and then suppose the next one. So, now j changes and j plus 1 is pointing here. Now, there will be a swap here. So, this is 12, say 12 and 70 will be swapped. So, 2, 50, 12, 70. In this way, I will go on up to this point. And next, so ultimately in this iteration, ultimately I will have this heaviest element, say 70 is the heaviest element coming over here. Then I will be decremented and I will come here. And then for this zone again, I will do the same thing as I did till now, right. Exactly that is being done here. So, I will be doing this and then I will increment, I will decrement n a little bit and I will go on doing this. I will be then looping, doing the same loop again for one level less. I mean the last element is already having the heaviest element. So, I will do it among the remaining part. So, this part is already covered. So, I have decremented it. So, I will be now playing in this zone, and once that is done, this part will also be covered. I will be playing in this zone, I will be playing in this zone, right. And in every zone, so once every time I am deciding on the zone, okay, n, n minus 1, n minus 2, like that it is going on, and every time I am doing this loop for each of the pairwise element comparison, and thereby I am pushing the heaviest element at the bottom. That is the code for bubble sort. However, this swap keeps, I have not yet explained this swap. Earlier we have seen that if we do swap in any arbitrary way, for example, if I want to swap two variables, say I write swap int a int b. Let me do it here. Let me do it here. If I do it like this, int, sorry, if I just do swap int a int b, and inside I use another variable temp, temp gets a, b gets a, b gets a, and a gets, sorry, a is stored here, a gets b, and then temp has been remembered there. So, b gets temp, and so this was my function return. So, here suppose a was, when it came, it was called with x and y. So, main program called swap with x and y, and x was 5, y was 7, right. So, x was a location here 5 and y was a location 7. Now, when it came here, a was a local location, and I know that the functions are called by value. So, 5 was copied in a and 7 was copied in b. 7 was copied in b, and then by this temp became 5, b became 5, and a became, where is 7? B was stored in a, sorry, this was stored in this became 7 and this became 5, all right. That is how it was done. So, 7, a was 5, so temp was 5, 7 went over here to a, and here 5 was copied again here. This was fine. So, the swapping was done by A by B, and then when I returned, no change is reflected in x and y. That was the problem. So, we will now see how the swap function can be implemented, but and again another point is here I have just done return. And a function can return only one value. I could not return A and B to the main function, right. So, how can the thing be managed? So, that after the swapping the result is reflected back in the main function. We will see that in the next lecture.